Hi Venkat. Venkat, where is Bhaskar?
Connection Bhavan. Dia, sorry, Shushri, he will be joining Shushri. Hello.
Okay. Hi, Bhaskar.
Hi, Sushri. Good evening to you.
Hi, good evening. So we'll just wait for another 10 minutes, 5 minutes.
Sure,
Yeah.
sure, sure.
They're still joining, I can see. So
Yeah. I'll just try to download the PPT locally, maybe, because I gave the access. Or I can just share it from. Sushri, can we just see oh, yours?
Yes, Bhaskar, you were asking something?
No, I'm just presenting it. Can you just see how the things are?
Yeah.
It's going this way. So it basically starts with, okay. So you're able to see the first slide?
No, Bhaskar, not yet.
Oh. So share screen. Let's see. Can you see it now?
Yeah, now I can see.
Okay. So you're able to see the full Divami,
Yeah.
the full screen, right?
Yes.
Okay.
Just like close your download thing. Yeah. Hi, Bhaskar.
Hello. Who is this?
Good evening to you.
Hi, good evening. So we'll just. Sorry, so I'm broadcasting it live on YouTube, and it's like little delay is going on, so that's why it was echoing. Okay, Bhaskar. So we'll get started now. It's 6:05.
So, okay, not joining.
Okay. Hello everyone, and a very happy New Year first of all, and thank you for joining us on our first webinar of 2022. As you know by numerous social media announcement and email blast as well, that this is a webinar on Flutter and on which I have no idea. So that's why we have our in-house expert Bhaskar, who is the technology head of Divami, and he will be guiding us through it. Bhaskar, please start sharing your screen and start with. Guys, I encourage you to type your questions so that Bhaskar can answer them. And it's up to you. If you want to wait until the last and ask questions, then it's up to you entirely. But it's a very open platform right now. So please don't hesitate and ask your questions.
Srishti, you're able to see the screen?
Yes, Bhaskar, I can see.
Okay. All right, so let's start it.
Yes, please go ahead.
Hello, everyone. Namaste and good evening to you all. I was just wondering when I started this session, when I've been asked about giving a session on the Flutter and where we are heading with it. I thought multiple times on should I just concentrate on Flutter and then not go here and there. But then I felt that it would to give a holistic picture of the entire thing, and then focus a bit this time on the Flutter part of it. So I would try to cover the different platforms that are out there that we think as cross-platform kind of a thing. Are you guys able to hear me, Srishti?
Yes, Bhaskar, loud and clear. Yeah.
Very nice, very nice. All right. So I just thought, like, I'll try to give you a holistic picture before I, get a get a detailed presentation, maybe in the future, just on the Flutter part of it. But here our discussions will be mostly on the different frameworks that are available, and then how Flutter would be a better option, or what is the design of the Flutter, some of the installation issues that we have seen, and then how do you overcome those, and what kind of an applications we can build with Flutter. So that's our main agenda to cover today. Mostly this thing that it's a introductory session to the cross-platform things, rather than just focusing on the Flutter. But Flutter would be our main aim. Our target would be the Flutter too. But at the same time, think it as a holistic picture. Now, in this session, the agenda would be to cover cover the hybrid and native cross-platform things. Then we would go over the things on the Flutter side of it, what Flutter means, and then what framework is Flutter, what languages does it use. And then we'll go through what are the available platforms that are available, and how is it different than compared to the Flutter platform. And then how do we, as a manager, as a developer, how do you make the choice? So that's about the agenda part of it. Now, coming to what is the cross-platform development, right? Developing apps for the smartphone platforms can be really frustrating, right? You guys probably know that you need to be proficient in different languages. You have to be knowing like various different IDEs, right? Each IDE again comes out with separate language for it. And maintain code bases for Android, for iOS, right, etc. And these things has to be written in either Objective-C, Swift, or Apple's Xcode IDE, right? So when you're writing these native apps for multiple platforms, each app has its own version of the code base, right? That needs to be developed, and you need to update that native app for each supported platform independently. Usually that happens with multiple teams as well. Sometimes it can be one team, sometimes it can be multiple teams. So it's the thing is like developing for the cross-platform becomes a little painful when managing the multiple languages, multiple tools, multiple teams, multiple the check-ins and all these kind of things. So the app development usually for Android, it can be Java or Kotlin, and you use Android to develop the apps on Android. But sorry, it's a Google Android Studio would be used to develop Android apps using Java or Kotlin. And similarly, the Objective-C or the Swift would be used on the Apple X code base, Apple X IDE. And then we talked about the separate code bases and then separate teams as well. So the next slide is about what is cross-platform development, right? So in this, I would say in general, there are two types of cross-platform apps. Those that use the web technologies and those that are translated to the natives, right? Those that use the web technologies usually are responsive web pages, right? You develop the web page in a responsive way, and those responsive web applications will be accessed on a mobile applications browser window, and then you'll see all the responsive pages out there. And these applications are natively deployed on a web server or somewhere, and you would basically access them, through your mobile web browser or a desktop web browser. They aren't available in the App Store. So as I said, those web pages will be deployed somewhere on a web server. And the next one is those that are translated to native apps, right? So the ones that are translated to the native apps, they basically make you feel like they are more like native apps, whereas they are not native apps, right? They are transformed into the native apps. They use the browser's built-in, OS built-in browser components of the platform, and they can be made available on the App Store as well, right? These are also called progressive web applications, right? So some of the shortcomings of this would be it doesn't have the full functionality access to the OS. It probably gives you some access to the OS, but it doesn't give you the full access to the OS. And then you may need to have some kind of a plugins to have access to the rest of the services, or let's say components like camera or geo locations, etc. So when you don't go for these kind of things, right? When you don't go for these native apps that are translated, you usually don't go for it when there is a performance need, right? So because there is a translation layer that is in between, right? That actually rendering with the browser component. So there would be a performance hit. And when you're trying to target a specific platform, then rather develop that for that particular platform rather than developing a web application and then translating it. And then when your apps need to make use of certain other resources that are not available for the native app component, then also you don't go for it. The next thing is about the hybrid class platform. So these hybrid class platforms basically are mobile apps that are derived from web apps, right? They are built using HTML and CSS and JavaScript. The web application on the left side with the HTML, CSS, and JavaScript would be converted by the hybrid app framework into a native app. The one that you are seeing with the green on the right side is that native app that's get converted. And the result of the conversion process is basically an app that can be listed in the App Store. So every modern platform includes a built-in web browser component, right? It's generally called WebView. So you're going to see that WebView on top of the hybrid app. So these hybrid apps usually runs within the build of the web browser component of the operating system. And it includes all the resources that needed for the app to run locally. So this is the kind of hybrid cross-platform thing that happens. Now, in case if you're hybrid cross-platform, this is just done in a vertical fashion. The web app, including HTML, CSS, and JS, using the HTML rendering engine, would be converted to the web view and then access the mobile operating system. But in case if some things are not available through the web view, usually the platform would provide some kind of a plugin for you to access the services. Now, one of the hybrid cross-platform thing is the Cordova. So a web app would be given to the Cordova and then in Cordova you can include different packages for Android or iOS or Windows, and then it converts the web app into the cross-platform solution. So here the interesting thing to know is the hybrid cross-platform solution. I'm trying to compare with the language here, right? So in this, what exactly is happening is the hybrid framework is similar to the Java platform, similar in the sense the semantics of it would be similar. If you guys know how the C++ works or how the Java works, it's you know that it's quite different. Java is compiled into bytecode, and then bytecode is loaded into the Java virtual machine. The virtual machine will again target it for specific platform, and then it works because that particular JVM is loaded on that particular operating system. Whereas in C++ and then C, it actually links everything into one component, and then it generates an executable which can be deployed and then run on specific platform. So here, if you see the Java code on the left side, Java code gets compiled into into the bytecode using the Java compiler. Then it converts to the JVM. It's deployed onto the Windows or Mac or Linux, and there that particular JVM will translate this bytecode into the machine code and then runs it on that particular machine. So if you see the hybrid cross-platform thing on the right side, the web things like HTML, CSS, JavaScript would be converted to a hybrid app by the hybrid framework, and then it will be deployed onto Android, iOS, or Windows. The Android, iOS, or Windows will give the hybrid app to the web view, and then it gets rendered. So that's basically about the hybrid app. Now we'll come back to the native cross-platform solutions. The native cross-platform apps are basically written in languages that are given in the left side, right? Yeah, it can be more than this. I just gave you like C#, ES, JavaScript, and any other languages, right? These languages are not native to the mobile operating system or any other operating system for that matter, I think. Even C# is not native, JS is not, I believe, ES is not. So the native app framework is responsible for compiling and then translating the code written into the apps. So this native app framework would basically, what it does is it takes these languages and then converts into the native code, and then that code is deployed onto the OS. Now it looks like a native app, and then it runs like a native app there. That covers you the hybrid and then now the native cross-platform things. Again, in the native applications also, there are again multiple kinds of apps. I don't want to get into that aspect of it, but the difference between the native cross-platform and then the hybrid, you can see here, I gave the same comparison that I gave you earlier. Here, it's basically app code is compiled like the C++ thing, right? App code is getting compiled into different object files, and then a linker would combine the libraries and then objects files and then deploy it into specific platforms. So similar to this thing, the app code would generate the native app using the native framework, and then that native app can be run targeted for iOS, Android, or Windows. This is now native app, which is having the same performance as code that is the machine code or operating system code that is running on the machine. So now what is Flutter, right? So basically covered both the hybrid and then the native apps. Flutter, see this guy, Ian Hexum, he is the one who actually started a long time back along with some other folks as well. But at that time, the definition of it, I crossed out what is not applicable as of now. The Flutter is a high performance cross-platform application runtime, and its corresponding frameworks. It's designed to enable multiple code reuse across multiple platforms, while also allowing applications to interface directly with native services. So the Flutter actually has evolved. Earlier, it used to be only for mobile applications. Now it's got translated over the years to support other applications as well, other platforms as well. So I striked off the mobile down here. Android, iOS, as well as desktop, and then web also has been supported now. So it's basically an open source platform developed by Google to build the native apps from a single code base. without compromising on the quality, speed, or performance. So these three things are very important when we are choosing a technology for our applications. This is used to develop apps for platforms like Android, iOS, web, and then desktop. The programming language used is Dart. We'll come back to this in about a few minutes again. But let's go back to this is in contrast with whatever I have showcased earlier about the hybrid and the native apps, right? So in case of the native apps, if you are going with a single platform, like say Android, and then you are using Android Studio or iOS Studio, and then you basically develop the applications for the Android platform and then deploy it there. Similarly, for the iOS applications, you develop your application and then deploy it, the native coding in the iOS, and access the platform services. So these are catered to either Android or to the iOS. Now, this is the same thing that I mentioned earlier, that the WebViews. So the apps would be converted into the WebViews, and then it gets rendered onto the canvases. Sometimes there will be a bridge in between to translate your application code back into the platform code and then execute it. So in any of these that you're seeing down here, there would be a performance hit because of these WebViews, these bridges that are coming in. So anywhere there is an additional layer, there will be performance issues that might be coming in. Now, coming the Flutter, the difference between the other applications and the Flutter is that here it renders the app itself rather than the platform to do so, right? Your Flutter application services renders the app itself. That means it is very super fast. There is no in-between kind of a things here. Now there is no WebViews, no bridges or anything. It directly interacts with the canvas. It just gets to the canvas and then displays all the things that is required on the canvas, right? There is never any bridge or context switch that is happening here. So because of that reason, it's quite faster. Now all that the Flutter requires here is the canvas to render the things on the canvas. That's it, right? So this is the difference between the other platforms and then the Flutter platform. Coming to the framework, the entire framework for the Flutter is developed using Dart. Right? So Dart is another object-oriented language. It's basically the Flutter's language. But underlying the Dart and then the underlying engines all are written in C++. So so there is this material. I'll come back to this material and then widgets in a minute. So this is about the Dart framework and then the engine that has been written in C++. Maybe it's because of the thing that the entire engine has been written in C++. That's quite faster, I think. Now here in Flutter, the widget, right? It goes from bottom up. Thank you. So this is the left side of the thing is the main Dart code. This is the Dart language that I talked about a few minutes ago. So that's the Dart language on the left. These are the kind of, everything is a widget down here. So I just kept this widget thing down here. It uses the material and then themes. It has it can be compiled, the Dart code can be compiled in two ways. I think the guys coming from Microsoft background, maybe C# and all, they might know it. It can be compiled as in just-in-time compiler or ahead-of-time compilation. So when you are doing the just-in-time compilation, you can actually edit the code and then see the output rendering on your device immediately. You don't have to compile and then do it. Whereas in the ahead-of-time compilation, I know JIT will be again performance hit a bit, but at the time of ahead-of-time compilation thing, it basically the compilation specifically happens like that C++ thing, right? It happens for either Android or iOS. So it compiles to that particular platform and then keeps the code ready. It's not like it's the bytecode again, it has to convert to the machine code and then run it. It's already converted to the machine code and then ready to execute. And that's what happens here with the AOT compilation part. Right. Sorry, installation part. When you are installing the Flutter, you can install the Flutter from, I think it's there on the web, you all know it. So when you are installing, you will find a lot of issues, right? So the thing that I tried a lot of things to resolve certain aspect of the errors, but I found that the best thing to do is like install the HBrew. That would take care of a lot of things basically. So I installed the CocoaPods and all that stuff separately. I tried to do all kinds of installations like sudo gem install with the specific versions and stuff, but it was not successful. The first command works, but the second command doesn't. So that's a little strange. But then I had to switch back, I think, to HBrew, and then HBrew has done a fantastic job in getting all my errors resolved. Once you install it, then you install the CocoaPods and then run your Flutter Doctor, then you would be a champ. There are other methods to do the installation, like say sudo gem update and then sudo gem install CocoaPods. This thing I haven't tried it, but looks like these things might also work. This is the installation success message that you're going to get, like say all the check marks. Whenever there is an X in the things, that means that needs to be resolved before you go ahead and then do the development on the Flutter kind of thing. So the Flutter and then the Flutter framework and then Flutter installation being successful, then the next step would be to start doing your development. This is one of the applications that's been developed in-house by the Diwami teams. This is one of the fantastic applications I would say has been done by the Diwami. There is a lot of features in there. I just placed because of the client. If you select a project, there will be all 9 projects coming in. There will be more screens where you will see the other stuff, but I just copied a few of them here. This is one of the mobile applications that's been developed on Flutter. The reason I would, this is in the next one that you're seeing here, with the Flutter, the Google team had a request, right, saying that they wanted to build some old application, which is like 14 years old. They want to do that in Flutter, but they don't want to change the skins. As you guys know, with this material and then Cupertino themes, there will be all modern icons, modern look and feel would be there. So if you use the application as is, then you would get a modern look and feel kind of a thing. But they wanted to do something like this desktop app, right? So for that, they wanted to use the Flutter. Now, the layered architecture that I have showcased earlier looks like, if you see here, the layers are like foundation, animation, painting, widgets, and then these are all like layers one after the other. The beauty of the Flutter is that you can change any of the layers if you want. You can replace any of the layers. So what they did was the Google team went ahead and then removed this Cupertino and then material themes. The Cupertino and then the material themes, they removed it and then they replaced it with the Chicago theme, right? So with that, they were able to, now they replaced these two things, which are enough for them to come up with this solution that they wanted. So the one that you are seeing on the left side is the old original application. The one you are seeing on the right side is a new application that's been developed on Flutter. So you can see here, it's the look and feel wise, I think more or less it's almost the same. It's 99%, I think they are able to achieve it. Now, the reason that I bought these two things, sorry for going back, the reason for bringing that, you can build the modern mobile applications, and also you can customize you can actually remove in the framework itself, whatever you want to replace with something, you can do that and achieve what you want to do. So building this kind of a tough things, or it's not that easy probably with the other frameworks. And they built this replaceable frameworks kind of thing. Now the other cross-platform apps that are available include the reactive native, which basically creates the apps for the Android and then iOS using React. You still have to go back to maybe the React web applications would be developed separately. Cardova mobile apps. Cardova is basically, again, the hybrid thing that I showcased, where it converts the HTML, CSS, JavaScript applications into the native app, right? So here it's not a true app here. So you basically bundling the HTML, Java, CSS into an app kind of a thing, and then pushing it to the App Store. That would be rendered into the WebViews rather than running it as a true native application. Which is the Ionics cross-platform framework. It's also built using the AngularJS and then Apache Cordova. It says you can also build web native apps, create cross-platform iOS and web apps with the JavaScript, HTML, and CSS. So this also looks to me like it's similar to the earlier Cordova hybrid things, where you can render it into the web views. There is native script, and then there is Xamarin. Xamarin is also one platform which is developed by the Microsoft. So using Xamarin also, you can actually develop the applications for Android, iOS, with the .NET and then C#. Here there is some distinction and then debate that happens whether the app that you are developing will have the business logic separated out and then the front-end logic separated out, or you're going to have a combined logic into one. So in that it truly doesn't reflect that it's a single code base. That's what I mean to say that. Now here is some of the comparisons that I got from the web. Xamarin and then the Flutter, these are mostly the well-known things. Performance is great with the reactive and Xamarin. Flutter seems to be excellent. Languages used is Dart in the Flutter, C# in Xamarin, and JavaScript in native. Quality is around 90 to 80% in Flutter, whereas 90% in React and Xamarin. Community support is not that great for the Flutter. That is one of the biggest drawback that we are seeing. And the widgets wise, you can also customize in the Flutter. There is hot reload that's available in the React Native as well as Flutter. Flutter tools and technologies. So it's to just give you a summary of guys. The Flutter is basically open source UI kit developed by Google. So because Google is backing up on this, we can rely on the platform. They are continuously doing and then upgrades on the Flutter from mobile to desktop and then web. So they are gearing up to make it a big thing. So you can build the cross-platform native apps. It integrates with tools like Angular and then Visual Studio, both of them. If you see the checkbox that you have seen, there is this Android Studio things are there. And then Visual Studio, you have to add it as a Dart, and then this Flutter, you have to add it as a plugin. You use the programming language, and then it's a single code stack developed for multiple platforms. Where Flutter excels, it's excels with respect to the speed. It's all widgets. It's Dart is a modern programming language as well. With a little less code than compared to the others. The benefits of the Flutter, I just combined the pros of Flutter and the cons of Flutter here. The pros of Flutter, it's open source, single code base, hot reloading. So hot reloading helps with respect to, you're running the app, you see that there is a change that is required, and then you make the change and then it gets reloaded immediately. So that hot reloading comes into effect when you're doing the debugging and then you want to change it and then you want to see it in the app immediately. You don't have to reload the app. It gets, it's cost effective, it fixes crashes and then continue debugging. I covered it. It includes the modern framework, reactive style framework, 2D rendering engine, ready-made widgets for both the Android iOS using Material Design and Cupertino themes, developer tools included. Cons of Flutter, user support is not usually takes more size. As with any other cross-platform things, the size of the code probably is quite more. Developer needs to have another language to learn. Project manager or CTO manager, then how I'm going to make a choice, right? It depends on several factors probably, but I just put down like 4 of the things here: the time to market, the development cost, the performance is also one of the major things, and framework output related to the native apps. As a developer, I would choose the platform based on the learning curve, knowledge of the native platform, and the developer tools that I have to go with again, right? What tools that I'm familiar with, and other tools that I have to learn, and then single code base potential. So if I have to update, go there and then update iOS and then come here and then do the Android, probably that might be a little overhead. So I'll probably choose single code base potential. The next steps would be with respect to, I would look at the support, whether what kind of a support is available, what kind of a documentation is there, what it is supporting, and I'll probably compare it and then assess the current talent as well. So based on these steps, I would probably say like why I would go with the Flutter. So this is what it is, guys. Make it work, make it right, make it fast. All right, so that's the take on this. Anybody has any questions? So this is basically preliminary things. It's not, doesn't cover in-depth of stuff. Maybe by this, you would have got an idea of what the hybrid app is, what the PWA is, and then what Flutter does, and then comparison of different frameworks that are there. Actually, I would React Native, Xamarin, Cardano, all these different applications. So happy to you all, guys. Thank you, and I will take any questions if you have.
So Bhaskar, I think you explained everything very beautifully. No one has any doubts. So that's a good sign, I guess.
Thank you. Yeah. See,
Okay.
we can.
Yes, Bhaskar, please.
Definitely, I think we can have more in-depth sessions on just the Flutter also in the future with the development teams on what you can do with the Flutter. But this session was very important, is what I felt, to start with on the Flutter or any other cross-platform things, right? So knowing this, you can step forward in knowing better about the other things. So without knowing how we are heading, then we really don't know what choices that we are going to make, how it's going to be in the future, whether it's going to be the best choice that I made or it's going to be the worst choice. Right? We need to understand all these aspects of it. We have to weigh in a lot of things. All right, Sushri, thank you.
Thanks, Bhaskar. Thank you everyone for joining. Yeah. If you guys have any questions, Bhaskar put his email ID. You guys, I also put my email ID in the webinar page. So please reach out to us, and probably, as Bhaskar mentioned, there is too much to go on. Like, we have to go in depth. So probably we can have further sessions. Okay. Thank you, everyone. Good evening. Bye.